Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. Hello and welcome back to another episode of this epic podcast. It's been a while, I think 1 month, or maybe even more. And to be honest, not a whole lot happened in that time, again, like last time. A lot of work, a lot of non-technical stuff, but I think there's enough material to do one podcast now, and it should be semi-interesting. I'm not even going to say what the topics are, so you'll just have to listen along, because that's how we do it here. Let's start off with PCB failures again, for those who are following along at home. Every once in a while I make a PCB, sometimes for work, mostly for work, sometimes for myself. I haven't been making a lot of PCBs for myself lately, but I think I made 4, and let's see what went wrong. First one, not enough copper plane to act as a heatsink for a diode, so a diode got very hot. I have to fix that in the next revision. Next PCB, I screwed up a relay terminals of a double throw relay. So screwed up 2 terminals, had to redo that in another revision. Another PCB should be okay, and the problem is I haven't got feedback from a customer, so what does this mean? Feedback is important, so what I'm trying to say is we're good people here at CBA Podcast, so send us some feedback, really appreciate it. So we'll probably read your letter on the air or sing it if you want, so just send us some feedback, let us know how we're doing. And it's always appreciated, so people should send feedback about everything. Then there was a little PCB I did for myself. It's a long PCB, I think 6 centimeters long or something like that, 1.5 centimeter thick, and it's supposed to be like an inline PCB, power coming in, power and signal going out. It's to control a WS2812 LED strip and some other stuff. So there's a LDO on board, push button, I think an LED or something like that. SD card lid, SD card socket, so you can put an SD card in there, and an I/O signals, one signal going out, one signal coming in, and some protection. So the idea is you can put this like in line with a cable, and then just heat shrink the whole cable, and should look nice and be semi dust proof, something like that. So maybe I have some pictures of the finished PCB when this podcast airs, but maybe not, depending on when the parts arrive. Okay, anyway, so that was pretty boring. Let's go on to other boring stuff. Most episodes I am very eager and very enthusiastically telling about events coming up, and me promising to go there. And of course I didn't go there, didn't go to a few events. I was a Maker Faire in Berlin, 18 and 19 May. Of course I didn't go too far, and I had other stuff to do, or I didn't want to go, or whatever. Then there was the SEC Retro Division meeting, 25 May. I wanted to go there, but actually I went swimming instead. Unfortunately, it's only 4 times a year, that meeting, but other stuff to do. Because that same day, there was a Hackalot workshop, and Hackalot is in Eindhoven, in Hackerspace, and that's much closer by, because I live in Eindhoven myself. And there was a workshop about laser cutting, with a laser cutting machine that was there, and also vinyl cutting, or actually cutting material with an actual CNC driven knife, basically. So you can draw your pattern using a vector drawing and then have the machine cut it out, something like that. So you can make your own stickers, or your own cardboard art, or your own from tape. You can cut all kinds of stuff. It was pretty nice. Also laser cutter, I took a look at how it worked, and I think I know roughly how a laser cutter works, or how to use it, not how it works, but how to use the software and so on. And it was pretty similar, but some other software than I'm used to. So I'll just have to give it a try, but the quality seems to be quite okay. And it's very nice that I have a key to a place where I can go to laser cut stuff 24/7 instead of having to make an appointment and so on. And so it costs a little bit. I'm not sure how much. I'm not going to say it here because I would probably say the wrong amount, but they charge a little bit for that, and rightly so, because laser tube costs money, and the maintenance costs money, and stuff breaks down and so on. But I pay on an hourly basis for when I use a laser cutter right now, so it's not much of a difference for me. So this is much more convenient. I can access it whenever I want. I have a key to the place, so this should be quite nice. So next time I have something to laser cut or cut with a CNC blade cutter, I'm probably going there to give it a try. Of course, you can come by as well. Just see the website. I'll put a link to the website in the show notes, and you can come by. I think the laser cutter and also probably not the CNC blade cutter, but the laser cutter requires you to have taken some kind of workshop or at least a guided tour of what to do and what not to do. So, but you can at least look at it or under guidance use it and see what it's all about if you like that and live in the neighborhood. And now let's talk a little bit about physics. I mentioned in the previous episode already that I'm doing a little bit more sporting now. Or as a matter of fact, I'm doing some sporting now. I used to do nothing, now I'm doing something. So that's an infinite increase in activity on my part, so that's good. One of the things I like to do is climbing. And one of the types of climbing I like to do is top rope climbing. That's indoor. You have a artificial rock wall, let's say that, with overhangs and things you can stand on and hang off. You climb in a pair. One person is the belayer. He's a safety person. He remains on the ground. He or she remains on the ground. Hold a rope using a safety device. The rope goes up from the person, up the wall, 10 meters, let's say 10 meters, through a pulley at the top of the wall. And then the rope comes down 10 meters and is attached to the climber. So that's a starting position. And the climber climbs up the wall. And while he or she does that, the belayer pulls the rope tight, so removes the slack from the rope. So if the climber falls, he or she doesn't fall far, because there's not much slack in the rope, at least there shouldn't be. Now, fact of the matter is, when I'm climbing, I'm scared shitless, and especially when I'm high on a wall. I'm scared of falling, and I'm more scared of something breaking. So there's some stuff that can break. First of all, you have a belt, let's say that, or a harness around your waist, which attaches through a metal ring, let's say that, to a rope. So, and the rope, in the end of the rope, there's the belayer, the safety person. He or she also has a metal safety device that can also break. So you basically have a few things. You have the belt of the belayer on the floor, the safety person who is standing on the floor. Then the metal thing on the belt of the safety person. Then the rope between safety person and climber. I guess you also have the pulley at the top. Didn't even think about that, but that's one more thing. Rope comes down to the climber. Is attached through a metal ring, let's say that, to the climber, and attaches to the climber's harness, to the belt. So all these things can break, I guess. Now, I did a little bit of research, and internet research, let's say that. And it turns out that the rope, I think, is probably the limiting factor. So I think the thing that would break first is a rope. The metal rings between the rope and the harness, they probably won't break. The harness itself will not break. It's super, super strong. Although I hear it make sound when I, put weight on it. But whatever, let's just ignore that. So let's focus on the rope a little bit. These ropes are not stiff, not like normal rope you use to tie something together. They are semi-elastic, so they can stretch a little bit and absorb energy slowly when in case of a fall, and so the peak force is minimized, or at least less than with a non-elastic rope. What we use during climbing are so-called single ropes. That's a 10mm diameter, around 10mm nylon rope. And a rope is rated, among other things, a rope has a rated impact force. That's a maximum force that the rope can withstand, or is guaranteed to withstand. So that's all very nice, but you can find these specs for a rope if you buy a rope, but that doesn't tell me a lot. There's a number, a kilonewton. It doesn't tell me a whole lot. So what I was searching for is a formula that will tell me how much force there will be on a rope. The force that the rope will see is dependent on the mass of the climber and the length of the total length of the rope, and the height he or she will fall before the rope starts stretching. So mass of the climber, the height he or she will fall until the rope starts stretching, and the length of the rope there is to stretch. So basically the length of the rope to absorb the fall. So that last thing is defined as the fall factor. Fall factor is the height the climber would fall before the rope he or she is attached to starts stretching. So the free fall, let's say, before the rope starts stretching, divided by the total length of the rope there is to stretch. It's quite interesting actually, because if you have 100 meter of rope there is to stretch and you free fall 1 meter, compared to 2 meters of rope there is to stretch and you still fall 1 meter, the total force will be much higher in the second situation, because there's not much rope to absorb your fall basically. So to get an idea of what a fall factor is, or what a fall factor of 1 means, if you are bungee jumping and you're standing on top of a bridge or something like that, with a rope attached to your foot and the other end of the rope attached to the bridge, you jump down. So per definition, the free fall height is exactly the rope length, because the rope is attached from the point from which you fell, right? So in that case you would have a fall factor of 1. So like a classical fall bungee jump is a fall factor of 1. And the less rope there is to absorb the fall, or the higher the free fall is, the higher the fall factor is. And the fall factor tells something about the force that the rope will see. So I did some calculations for myself, and 2 situations that might be interesting. I'll spare you all the numbers because I think I may have put the complete audience to sleep already, but whatever, it's my podcast, so suck it up. 2 possibly interesting situations are when there's no slack in the rope at all, so the belayer, that's the security person on the ground, does his or her best and pulls the rope tight all the time to remove all the slack. So in that case, in my case, my body weight is, let's say 100 kilo, let's say gravitational constant is 10 instead of 9.8. So the force that the rope will see is always 2 kilonewtons. Now these ropes are rated for 7 until 8.9 kilonewtons. So what I did was look at the local climbing gear shop, and they have a number of ropes in this category, and they are rated by impact force, so the maximum force they can withstand. And the lowest was 7 and the highest is 8.9. So somewhere in that range are the ropes that I use. So if there's no slack, there's no problem, because 2 kilonewtons is like 30% of the weakest rope, right? So there's no problem at all. The rope will not break at all. And another interesting fact is, for the situation that we're using here, so there's a belayer, that's the safety person standing on the ground, attached to a rope. The rope goes up 10 meters to a pulley, comes down, and is attached to the climber who goes up. So in that situation, that if you do the math, the fall factor, so free fall height divided by the length of the rope to absorb the fall, cannot be higher than 0.5. So that's interesting, because it doesn't matter how high you climb, the force that is seen by the rope is approximately 85% of its rated force at all times. So it doesn't matter from which height I fall and how much slack there is in the rope when top climbing, you will never break the rope. You may plummet to the floor, but you will never break the rope. It's impossible for my mass. That's quite nice. And once again, there's a little bit of a simplified situation that I'm assuming that the friction by the pulley at the top and the friction by everything, by the stiffness of the rope or something like that, is a 0. So in reality, the rope goes through a pulley at the top of the climbing wall. There is a little bit of friction, so that means the effective length of the rope to absorb the fall is less, right? But there's not that much friction, I guess. Yeah, so there was a lot of rambling on, and it should be safe, because a lot of guys and girls are climbing there, and they don't give a crap about safety, and they do it anyway. Nobody gets hurt ever, so yeah. Anyway, this kind of calculation has a little bit to do with self-confidence for me, because if I see a difficult system like this I don't know much about, I don't know, if I look into it, how much unknown and difficult formulas will pop up, and how much background information I have to learn in order to understand the problem even. So my first reaction is not to engage that problem at all, but it's quite satisfying to do it anyway, and to see it's not that difficult at all, and actually you can get results with it. So result was that I simply cannot make the rope break with my mass, so that's cool. Right, so if that didn't put you to sleep already, there's even more stuff coming up. Some events that happened and didn't happen and are happening, and I did or did not go to. First of all, there's a T-DOS. I'm not 100% sure what that means already. I'm too lazy to look it up now. T-DOSE. It's an open source software event in the Netherlands. I'm not sure if it's yearly. I think it's yearly. Nice research there. And it's on a high school nearby, very nearby. And I was attending a stand there together with someone else from the Hackerspace in Eindhoven. That was quite nice. I drank a little bit too much coffee that day. I think I had 8 or 10 cups of coffee or something like that, maybe 9. So that was not super optimal, but anyway, it was quite nice. Nice conversation with people, and might do it again next year if there's a request. Yeah, I had some interesting talks, some not so interesting talks, but overall it was quite nice. Nice experience. And talk about Hackalot. There's a hackerspace in Eindhoven. I mentioned it a lot of times already. It's quite nice. My initial idea was to go there and to do projects with other people, so to do a joint project with other 2 people or 3 people or something like that. Each does his or her own thing. I never did that, so I haven't done that. But what I did do is like exchange tips and ways how I work, and listen to other people tell about how they work and tips about to making creative shit easier. So that's quite nice. So now it's limited to exchanging ideas. Maybe I'll do a project together with someone, but I think it always sounds better than it is in practice, I guess, because everyone has his or her own ideas of how the project should go and what's important and what's not. So not sure how well that will go in practice, but whatever. Maybe it'll turn up sometime. Another thing having to do with Hackalot is a member meeting. That was the 16th May. It was a semi-official thing. So the board, the members of the board, they showed their progress and the history a little bit of that year, what happened, where it's going, what's up for the future, and so on and so on. So it was quite interesting. So in a few hours I learned a lot of shit. So it was nice. I shouldn't say shit so much. Last thing, again, from Hackalot, is a barbecue. There was a barbecue the 1st of June. I think it's now the 3rd of June. I didn't go. That's not really my kind of stuff. I like to do things that are a little bit challenging to me, but this is like challenge overdose. So I might do that one time, but no, not this time. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.